Alright guys, this is the last video on sequences and series. There is one more lesson. We're going to do it live because it's all about using the calculator, and I just feel like I can answer and help you better if we do it live. Alright, today we're going to talk about geometric again. So remember, geometric sequences are when every term is in a direct ratio to the term before it. So you're multiplying by something. Okay, my tablet is not working. What's new? Okay. So it says each term after the first is a product of the preceding term and some common ratio. Therefore, to find the common ratio, divide any term by the previous term. The nth term can be calculated by, and this is our explicit form, two non-consecutive terms of a geometric sequence are called geometric means. So, just like we had arithmetic means meant missing terms, kind of, geometric means are the same thing. There's our formula again. A sub n equals a sub 1 times r to the n minus 1. And just a reminder that not every sequence is either arithmetic or geometric. There can be some that are neither. So here's just find the seventh term. So this is just, now they've told us it's geometric, so we know that we can divide this by this and get the ratio. So if the first term is 8, and the ratio is -3, a sub 7 would be 8 times -3 to the 7 minus 1, or 6. This is one of those problems where if you don't put the negative in parentheses, you will not get the right answer. Because this is 8 times -3 to the 6th, and when you have a negative to an even exponent, it should turn positive. You just always put the ratio in parentheses, you won't have trouble. So this is 5,832. And then we're going to talk more about geometric means. Alright, this one has two geometric means. That simply means there's two missing terms of a geometric sequence that fall in between 6 and 162. That means 6 was multiplied, not added, but multiplied by r 1, 2, 3 times to get to 162. So 6r cubed equals 162. We divide. 162 divided by 6 is 27. Then you have a couple options. You can do the cubed root of both sides, or you can do 27 to the 1/3 power, which is the same as the cubed root. I honestly like that better because I don't like having to find that cubed root button on my calculator, but I will show you where it is quick. Okay, the cubed root button is under the math here. It is number 4, or you could use number 5 and put a 3 here for cubed root, or any other root that you wanted to find. Okay, let's see what's happening. Why is it not? I hope you can hate this thing. There we go. You can also, like I said, I would have just done 27 to the 1/3 power. Then I didn't have to look for that silly button. Okay. So the answer was that r was 3. So to go back and fill this in, 6 times 3 is 18. 18 times 3 is 54. And 54 times 3 is 162. So again, this is kind of self-checking, because if it doesn't work out at the end, you know you did something wrong earlier. All right, find the first term of a geometric sequence. So to find the sixth term here, they did the first term times some ratio 6 minus 1 times, okay? It says the sixth term is 0.1 and the r is 0.2. So the sixth term is 0.1. I don't know the first term, but I know r is 0.2. And to find the sixth term, they did this 6 minus 1 or 5 times. Now these are incredibly little numbers we're working with here, but to get rid of times, we're going to divide. So I'm going to divide this over to the other side. 0.1 divided by 0.2 to the fifth power comes out not so little. 312.5 was the first term. Okay, so these are just a variety of geometric sequence questions. This one again has 3 means this time, between 7 and 567. So this time you multiplied by r 1, 2, 3, 4 times to become 567. If I divide by 7, I get 81, and the fourth root of 81, or 81 to the 1/4 power, is 3. So with r equal to 3, we can go back and fill these in. 7 times 3 is 21, times 3 is 63, times 3 is 189, and 189 times 3 is indeed 567. All right, the next thing we're going to talk about is finding the sum of a finite geometric series. A series means you're adding the terms up. So we want to find the total sum. There are some different formulas given here. This is the one that Delta Math uses, so that's the one I'm going to show you today so that you have a little bit of consistency. On our calculator, we do need a lot of extra parentheses, or we need to do this in pieces. All right, the sum of an infinite geometric series. We have not talked much about these. It's a little bit of a tricky concept, but when you have a geometric series where you are multiplying by a value less than 1, now it has to be the absolute value is less than 1, so somewhere between -1 and 1. So say I had a value of 1/2, and I started with 100, then 50, 25, 25 halves, half of that would be 25 fourths, 25 eighths, 25 sixteenths. We're down to 2, less than 2, okay? 25 over 32. Now we're down to less than 1. But that is getting smaller and smaller and smaller. So what you are adding, if it's a series, what you are adding on gets infinitely small. So therefore, here's another example. If you had this and you were taking 1/10 of it, do you understand that if you add those up, eventually it's just going to be a really, really small bit that you're adding on. And so you can say the series will approach a sum of this. Now this is when you are doing an infinite series. So we could write it as the sum of infinite terms. But this formula only works if you're trying to add up all the terms in a sequence where r is between -1 and 1. Okay? This is not going to be on a test, I don't think. Might be one question on a quiz or something, but it would tell you. All right. So again, here's from your notes. A geometric series means the sum of the terms of a geometric sequence. You can use a formula to find a finite sum, meaning when you want the sum of a definite number of terms, or a partial sum of an infinite geometric series, or you can find the sum that it will approach if it's got an r between -1 and 1. All right. This is one way you can use the formula, and I used to always teach it that way, but this is the one Delta Math uses. So I'm going to go with that one this year. And you need a bunch of parentheses to make this work if you're going to type it in all at once. Otherwise, you could certainly do a sub 1 minus a sub 1 times r to the n and get that answer, okay? And then take separately and divide by 1 minus r. That's what I usually do on my calculator. I do the top and hit enter, and then I say divide by 1 minus r. All right. So calculating that on your calculator can be a little bit tricky. Be careful. And then again, if you have an r whose absolute value is less than 1, you are allowed to find the sum of an infinite geometric series. And we're going to do a few of those, but again, not the focus of the lesson, really. All right. This is a finite geometric series they want us to do because they've said find exactly the sum of the first 12 terms. And these are getting bigger, as you see, so it wouldn't work as a infinite series anyway because r is more than 1. We need to find r, so we can take 7.5 divided by 6 or 9.375 divided by 7.5. Either one of those would give us r. So 7.5 divided by 6 is 1.25. The other one, yikes, I typed it wrong. Also gives us 1.25 or 5/4. You're welcome to use 1.25. All right, to find the sum of the first 12 terms, I'm going to just write it out. It would be the first term minus the first term times r to the 12th, no n minus 1 up there, over 1 minus r. Okay, let me show you the formula again. It's to the n power, not n minus 1. All right. So here we have 6 is the first term times 1.25 to the 12th, and it's all over 1 minus 1.25. Be careful you don't use a sub 1 down there. I sometimes get confused. It's r. All right. You could do this all at once. You would need an extra set of parentheses and like that. Otherwise, you're welcome to just type it in steps. So 6 minus 6 times 1.25 to the 12th. And then that whole answer gets divided by 1 minus 1.25. Okay. And these, most of them you could change to an exact answer. That one will not. I know on Delta Math it will, it asks you to round to however many places they decide. Like that one might be to the nearest hundredth. Just read carefully. So I'm going to write up here to the nearest hundredth. And we got 325.25 if we write that. All right. Now they move on and they talk about that. See how this is getting smaller every time? So what you are adding is getting very small. If you do 8 divided by 40, you get r equals 0.2, I think. 8 divided by 40. So they were multiplying by 0.2. Okay. So because r is less than 1, you can find the sum that the entire sequence would series would eventually approach if you add it up, because you're adding up smaller and smaller amounts. So you would say the first term is divided by 1 minus 0.2, and that's what will approach. So 40 divided by the quantity 1 minus 0.2 is 50. So if you added these up, you'd get 40, 48, 49.6, but then you're only adding another, let's see, 1.6 times 0.2 is 0.32 times 0.2 again. You'd only be adding 0.064. So do you see you're adding tiny little bits? So it's not going to get past 50. You're just going to add closer and closer to 50. All right, find the sum of the first 7 terms. So now we're using a specific number again. So it's the first term minus the first term times r to the 7th in this case, all over 1 minus r. So -1 minus, be very careful, there's a lot of negatives here, -1, r is 4, they were multiplying by 4, positive 4, over 1 minus positive 4. All right, because these are not to a power, it's okay to make this plus positive if you want. So 1 times 4 to the 7th is really just 4 to the 7th, but you can type it all in with the parentheses carefully. So -1 plus 1 times 4 to the 7th, or minus a -1 times 4 to the 7th, it won't matter. And I got 16,383, and then I'm supposed to divide that by 1 minus 4, which is -3. And I got -5461. Again, let me just do it the really long way here for you. The first term was -1 minus, and then it was -1 times 4 to the 7th, and then that whole top is over 1 minus r, which was 4. Okay, that's what I got over here is -5461. All right, find the sum of the first 16 terms in a sequence where, okay, they're not telling us r this time, but it says to find any term, this is called a recursive formula, remember that? It says to find any term, you take -2 times the previous term. So if we start with 1, and then we multiply by -2, and then we multiply by -2 again, and then we multiply by -2 again, this is what's happening, okay? So we are to find the sum of the first 16 terms. So you'd have the first term minus the first term times r is -2 to the 16th. And if you wanted, you could put that whole thing in parentheses and then divide by 1 minus r, which is again -2. Make sure you type that in as minus a negative, or you put extra parentheses, or you could just make it plus positive. What you cannot do is change this to plus positive, okay? Because the exponent power happens first. So when you type this, you could go 1 minus 1 times -2 to the 16th. And then you're going to divide by the quantity 1 minus -2. So I got -21,845. For the sum of the first 16 terms. I should be checking these. All right, find the sum of the first 20 terms in this sequence. Well, you could put in a 1, and you'd have 2 times 1.05 to the 0, which would be 2. And that's term 1. Term 2, you would put in a 2 up here, so you'd end up with 2 times 1.05 once, which is 2.1. You could put in a 3 just to see what happens here. 2 times 1.05 to the second then would be 2.205. But the bottom line is, if you divide this by this is r, remember? Because we had a sub 1 times r to the n minus 1. So it told us all along, really, that r is 1.05. I just wanted to show you. So if I do 2.1 divided by 2, I get 1.05. All right, so the sum of the first 20 terms is the first term, which remember we found was 2, or it was this out here, minus 2 times r to the 20th, and then we either need extra parentheses or we need to hit enter and then do 1 minus r. All right, so I'm going to use my hand calculator here. 2 minus 2 times 1.05 to the 20th gives me negative 3.3 blah blah blah, and then I'm going to divide it by parenthesis 1 minus 1.05, and I get positive 66.13 blah blah blah. And then it would round to whatever it asks on your Delta Math assignment, okay? All right, we're good with this. We already learned about this. We can just use our calculator to do the sum, or we could use the formula if we wanted. I could show you both, but I don't want this video to get long. It's under sum, and it was, I think, the sum of the first 11 terms, where the formula was. Okay, now this is where you got to get everything inside of these parentheses, so you're going to need extra parentheses. 1.06 to the n minus 1. Okay. Enter. And I got this number. Remember, the other way to do that is list, math, sum. List, ops, sequence. Then this particular one, the expression was 5 times 1.06 to the n minus 1, and I'm pretty sure you need parentheses around that. And the variable's x, and we were doing the sum of the first, was it 11 terms? This is how you would have to type it if you had a really old calculator that didn't offer you those little hints. You'd have to put it in with all those commas. And then it should come out exactly the same thing. 74.858 is what I'm going to write down. Again, we could have tried to turn it into a fraction. I have my doubts. Yep, that one's not going to work. Okay. So these are infinite, so we need to decide, is r less than 1? Well, it's pretty clear from this one. R is 3/8. This one, they are multiplying by 1/2. This one, you might have to put a number in. If you put a 1 in here, you would get 3 to the 0, which is 1. If you put a 2 in here, you'd get 3 to the 1, which is 3. If you put a 3 in here, you'd have 3 to the second, which is 9. So here r is 3. So there is no sum that you can find. You are just going to keep getting bigger and bigger and bigger numbers. If you add these up, it's going to approach infinity. It's not going to approach a single value. All right, so back over here, the formula, once we know that r is less than 1, the formula for the sum of infinite terms is a sub 1 over 1 minus r. Go back here and make sure that a sub 1 over 1 minus r. That's it. Okay. So this one, a sub 1 is 13. You could put a 0 in here. Put a 1 in here. That would become a 0. This would become a 1, so you'd just get 13 over 1 minus 3/8. We're going to need some parentheses there, or it's 13 divided by the quantity 5/8. That's what 1 minus 3/8 is, but it's 20.8. All right, and this next one, if r is 1/2 and term 1 is 10, the sum would be 10 over 1 minus 1/2, which should just be 20, because it's 10 over 1/2, and 10 is divided by 1/2 becomes 20. All right, and then we have a couple applications. Each year, the value of a car depreciates by 18%. If you bought the car for $32,000 in 2019, what will it be worth in 2024? You just need to subtract, okay? 2019 minus 2024 is 5 years, and you're going to do 1 minus 0.18 to the 5th, just like we did in the exponent chapter. Don't do anything crazy, okay? Because the first year we know this is the value. So after 5 years, you're going to use just a 5 up there. You're not going to do any, or you could do 32,000 times 0.82. All right. You don't do an n minus 1 or anything on this kind. You already took care of that in the fact that you were using years and you subtracted. 1, 1, 8, 6, 3, 67. I will tell you, the delta math questions like this, they ask you to round to the nearest tenth, which would be 0.70 or just 0.7. I don't know why they do to the nearest tenth when it's money. This is a delta math question. It says you rent an apartment that costs $900 per month during the first year, but the rent is going to go up. Okay, got to move that decimal over twice and add 1 per year. It's all of that plus 7.5%. What would the rent be during the 8th year? Okay. Now we got to think about this. The first year is this. The second year is this once. The third year is this twice. So this time we do need to subtract 1. During the 8th year, it would have gone up 7 times. So we have 900 times 1.075 to the 7th is 1493. And again, here it says round to the nearest tenth, which makes no sense to me, but that's what the rent would be. And remember, in delta math, you just put in the number, not the dollar sign. Number 14 says an employee agreed to a salary where his annual salary increased by 4.5% each year. He earned this for his 10th year. What was his first year? Okay, so he earned something the first year, and then it was multiplied by 1 plus 0.045. Now, his 10th year, he's gotten 9 raises, right? And he earned 50,081.41. So what I need to type is I need to divide that backwards. So I have 50,081.91, I think. Oh, it was 41. Okay. And then I need to divide this. Where's my cursor? I'm going to divide by all that. So I'm going to say divided by 1.045 to the 9th. And I could do 1 plus if you want. Or you could just add it, doesn't matter. And you get basically 33,700 was his starting salary. So he started at 33,700. Okay, to the nearest dollar, how much did he earn for the first 10 years of work? So the sum of the first 10 terms, where the first term, and then it's minus the first term, and it's how many terms you're adding. So it's 1.045 to the 10th all over 1 minus r. All right, I'm going to try to type quickly. 33,700 minus 33,700 times 1.045 to the 10th. Enter, and then divided by 1 minus 1.045. I got 414,112.66. So 414,000 he made in 10 years. All right, I think this is the last one. Yes, okay. A large corporate company has put out an advertisement in a magazine for a job opening. The first day the magazine was published, they got 90 responses. But after that, it's declined by 10%. So they got only 90% of them the next day. Or I can write that as the next day it was multiplied by 1 minus 10%. It declined 10%, okay? The next day, the next day was 90 times 1.1 minus 0.10 twice, and so on. So day 1 they multiplied once, day 2 they multiplied twice. Okay, wait a minute. Day 1 they didn't multiply at all. Day 2 they multiplied once. Okay, anyway, but they just want the total. So R is 1 minus 0.1 or 0.9. Now, what was the total for the first 16 days? Okay, so the first day, and then minus the first day times R to the 16 days all over 1 minus R. Okay, 90 minus 90 times 0.9 to the 16th divided by the quantity 1 minus 0.9 is 733.22. So 733 is the nearest whole number. Okay. If you have trouble on those on Delta Math, look at the example on one and then try again to decide if it's, 16 or 15 days or what's going on. All right, that's it. Good luck.